So I just want to quickly sort of survey the room here and see how many people are using Flink on top of Mesos already. All right, this is a great talk for you then. How many of you are familiar with DCOS? All right, a couple people. All right, good. So we're going to sort of go through this presentation in 3 parts. I'm going to start off by giving you an introduction to DCOS, which is built on top of Apache Mesos. And I'll also talk about some of the other components that are built within that to build up the DCOS ecosystem. So got things like Marathon and Docker and other things inside of it. And then I've got my colleague here, Ravi, who's going to do a demonstration. He's going to do one of our sort of basic pipeline demos to show you a workload inside of DCOS. And then he's going to go through a bunch of the options that you have when you want to go ahead and install Flink on top of DCOS. We have a UI and a command line tool and lots of great stuff for that. And then we're going to see how much time we have towards the end. I really wanted to cover some of the key features in the DCOS release 1.9 that just came out a couple weeks ago, because I come from an operations background, and some of those features in 1.9 are really great for handling containers and tracking things like logging and metrics and other things that are pretty exciting with this release that will help a lot with a lot of the data stream processing work that a lot of us are doing. So I want to start out just with a quick, what is this Apache Mesos thing? I think there's been some sort of support for Mesos in Flink for a little while. There's been talks, people have given talks about using Mesos and Flink together. But with the 1.9 or 1.2 release of Apache Flink back in February, there has been more support for Apache Mesos and DCOS specifically put into Flink. So that's why we're here at this conference, because this support is pretty new and we're pretty excited about the collaboration between the 2 projects. So Apache Mesos is basically a data center kernel. You install Linux on a bunch of servers in your data center. You install Apache Mesos on top of that, and you create this Mesos cluster. The Mesos cluster essentially is a pool of resources, CPU, memory, and just recently we allow GPU allocations as well. And so you tell your application will tell Mesos, I need this much CPU, this much RAM, this much storage. It will go out to your Mesos cluster and find somewhere in your data center where that can live. You typically don't really care where that lives. You can do some co-location of services, but you just look at what resources you need, and then it puts it where it needs to be. So that's pretty much what Mesos is sort of abstracting out your hardware, at least from a user level. You then have Marathon, which is a scheduler. So you can put jobs on Mesos directly, that's fine. But if you want to actually manage your jobs and keep them running and make sure when they stop, you can restart them and write other sort of scheduler things, you need a scheduler. So Marathon's kind of the default scheduler that you tend to use with Apache Mesos. This little picture here sort of shows you what a request looks like. You write a Marathon file. You put out a request to Apache Mesos, it goes out and uses algorithms to look up where it has space and where it makes sense to put that on the cluster, because you typically don't want too much stuff running in one part of the cluster, obviously. You want to, spread out resources, and Mesos is very good at that. And then it schedules your task. It'll dump it inside of a container on Mesos and then run whatever application you need to get run. The website for Marathon's a little bit hard to find. It's just a github.io URL, so mesosphere.github.io/marathon, if you're interested in looking it up. If you're trying to Google for Marathon, just type something like Apache Mesos and Marathon, because it's actually kind of hard to find. Using Marathon with Mesos also allows you to do things that are highly available, because again, you have scheduling that's maintained in there, so you can restart services and things as needed. So on top of Marathon and Mesos and all this stuff, the company I work for, Mesosphere, started working on a project called DCOS a few years ago. Almost exactly a year ago, the whole project was open sourced. So we now have an enterprise version and an open source version. My role within the company is working exclusively on the open source version. So we're only going to talk about open source stuff here today with DCOS. But what Mesosphere found as our customers were deploying Mesos was that they were all having similar problems with deployment of Mesos. So Mesos is really good at resource management, but it was actually kind of hard to interact with Marathon in a way that was user-friendly and easy to do. Because you've got these JSON files that are Marathon definitions, and they're great, but when you get a lot of them, you have to start managing them in some way. So we found that was becoming a problem. Task scheduling was a little bit of an issue. General like container orchestration and everything that goes with that. So you're talking about networking, forwarding of ports, communication between containers. We found that our customers were all writing their own specific tools to handle all of this stuff independently, and that's no good. So we wanted to put together DCOS to solve a lot of these common problems, and that's what it does today. It also offers things like logging and metrics. So we'll talk about this a little bit more later after the demo, but some of the really cool stuff that it's doing now is doing like full stack logging and metrics that are unified. So you can trace like a task ID through every level of it, so every level of the system. So you can look at it on the Mesos level and then up through inside of a container, being launched through Marathon. So when you want to pinpoint a problem, it's really easy to do that now. We also decided to put in a bunch of pre-configured apps, which is where something like Apache Flink comes in. We have this universe repository that's all open source, and companies and organizations contribute projects to us with some basic configuration. And do I have a slide about that? No. Okay. So the universe is a bunch of packages. Flink is one of them that are typically put together by someone who knows a lot about that application. They set some reasonable defaults, so you essentially have a one-click install if you want to try out something. So actually, Ravi is the master of the universe over here. He's the one who goes through all the commits. So when someone submits something to our GitHub repo, so they say they want to add, if they want to add Flink support, he'll go through and test it, make sure it works, make sure that there's good instructions, and help working with the universe stuff along with other people. If you were interested in more about DCOS, I'll be still talking about it, but our website's dcos.io. Quickly, just an architecture overview. This is actually, it looks kind of small. I'm not sure how well you can read this, so I'll sort of explain it. I mentioned that you can install, Linux and then Mesos and stuff on top of a bunch of servers, but you don't have to just use physical servers. Since it's just using sort of vanilla Linux, you can run it on anything really. You can run it, on your own physical servers. You can use it on virtual servers. I have a friend who just deployed DCOS on Linode because he was bored one weekend. I don't know, but that works. You can run it on your own private cloud. So if you're running something like OpenStack, you can use your private cloud. Again, just Linux or just any of the public cloud providers. We have mechanisms on the DCOS website to make it really easy to deploy on things like Azure and AWS. So that's where we typically tell people to start if they're going to try out DCOS. Give a spin on, go for a spin on the AWS templates and just get it launched. For testing, we also have a Vagrant install, so you can do it all locally, but your laptop needs to have like 16 gigs of RAM, which mine does, but yours might not. So that's sort of like the infrastructure you need underlying it. On top of that, you run Mesos. DCOS has an installer for Mesos, so you don't actually have to install that yourself if you're going to use DCOS. It can go ahead and install it all for you. And sort of in that DCOS layer, that's also where you have the networking and the forwarding and security controls. That's, of course, where the API lives and everything. And then on top of that is actually where all the services and containers run. So DCOS orchestrates it's sort of like the user interface for deploying whatever applications you want. So this is everything like Cassandra and Flink and Jenkins, say, if you're running that. We have packages for all this stuff. And then you can write your own applications. So you don't need to depend on our universe of software. It's pretty easy to write a definition. Not pretty easy, but it's not hard. It's just another, definition that you write. So that's pretty much how it looks. You interact with DCOS in a few ways. We have a web-based user interface, which Ravi's going to show you live here, but I just tossed a screenshot up here. the web-based GUI, you can pretty much do whatever you need to do. You can launch tasks, you can install software. You can even there's even like a JSON editor. So if you have a marathon definition and you just want to run that, there's a screen where you can just paste in your JSON and upload it that way. For the 1.9 release, we did a whole new refresh of the UI, so it's looking really bright and pretty. I was actually at a conference a few months ago showing off the 1.8 version, and it was really dark. So I'm in this like brightly lit conference venue showing off DCOS on my laptop, and everyone's like, I can't see anything. And I'm like, oh. So I'm super glad about this UI refresh. It looks really nice. Hey, look, there's the universe. I did have it. So this is just sort of a selection of software that you can install with one-click installs on DCOS. Again, in the demo, you'll be shown that you can, it's not just one-click install. There's actually a bunch of options that are presented to you if you want to go to an advanced installation. So that's the universe. And again, just through the web UI, you can just click to install something, which is super great for testing things out. The other two ways you can interact with it, there's a command line tool. It's cross-platform, so you can install it Windows, Linux, Mac. And then it's just a DCOS command, and you can do pretty much. It's pretty much it's an interaction with the API, but you can upload marathon definitions. You can start services, schedule tasks, all kinds of things from the command line interface. That's what I end up using most of the time. There's also an API, so you can script a bunch of stuff. In a lot of the demos that we write, and I think actually maybe the demo we're doing today, we write them in Go or Python. And then that's all just hooked into the API. So the API makes it really easy to script a bunch of stuff, which is what you're actually going to be doing in production for most of the time, especially if you have really large workloads. So that's DCOS. We can answer questions at the end if you have more questions about specifically like that basic sort of intro section there. But we had data artisans come and do a blog post for us back in February. And in that, I learned from that blog post that 30% of the people running Flink today are actually already running it on Apache Mesos. So it's good to be in this talk because a lot of companies are already doing it. And if you're interested in going about it, you're joining a great crowd of people. I mentioned that in version 1.2 of Flink, Apache Mesos and DCOS support is included. They have, in their release notes, there are some links to some of the resources, and we'll make these slides available afterwards. And there's also documentation on how to set it up with Mesos. We actually have a pull request out there to improve the documentation even more for Mesos directly, but the documentation has both DCOS and Mesos instructions for how to deploy Flink. And it ends up being actually pretty straightforward, so it's good stuff. So I'm gonna turn it over now for some demos. Do you want me to hold the mic?
So this is what the refreshed UI looks like. If you go and see on the dashboard, you can see the CPU allocation, memory, and the disks that are running on the cluster. So in this case, there are around 32 shares of CPU that are available on your cluster, which you can use to run your services, and about 110 gigs of memory and the disk allocation for this cluster. So if we go into the services tab here, we can see now we have improved options in DCOS 1.9 to run services either as a single container or as a pod. So I think Elizabeth's going to do a deeper dive about it a little bit later. And there's a field called JSON configuration where you can go and define the marathon JSON which you need to run on a cluster. And if you click on the install a package here, you would be redirected to Universe. So this is what we were talking about, pre-packaged set of services, where you can go and click on it, and within a few clicks, you'd be able to install this service on your cluster. So let's go ahead and try that out. So before we do that, let me also show you the number of nodes that are running on our cluster. So we have around 8 nodes. 7 of them are private, 1 is public, and let's go back to Universe.
Nodes are like the physical agents and stuff that are running Mesos.
So I go here, I see a Cassandra service here. So if I click on install, you would see two options. There's install package, which is a one-click install for the service, and there's an option for advanced install. So if you click on this, you would see the default parameters or config options that you can change. So in case of Cassandra, in the services tab, you see that you can go in and change the user, the amount of CPU, memory, heap that the Cassandra service would need. If you go to the nodes tab, you would see you can configure the number of DSC nodes or Cassandra nodes in this case that you want to run in your cluster. And similarly, for in the Cassandra tab, it's all the configuration that goes into cassandra.yaml when you go ahead and install it. And it's same for executor and task tabs. So let's review and install it. All right. So when you click install, if you go back to the services tab, you would see that Cassandra is starting to deploy now. If you click on it, you would see the tasks that have started to run on it. So the first one is the default Cassandra scheduler, which is the one which interacts with the Mesos API and brings up the Cassandra nodes. So in the meantime, let's also install a couple of other packages. So you see there are a lot of options for Kafka. Let's go ahead and install open source Kafka from here. Go back. Oh, I can just search here. Then I would also want to install Zeppelin. I also want Marathon LB. Marathon LB is just a reverse proxy. It's just glorified Nginx. So we see all the apps deploying here. Let's go back to Cassandra, and we see one of the nodes is starting to come up. So we can click on it, and it has an option to check the logs. So you can go through the logs and see what's really going on. There's an option to go through the standard error, and all of this would take around between 5 to 10 minutes to come up. So to save you that time, I already have a cluster with everything installed. So here we have Cassandra, Flink, Kafka, Marathon LB, and Zeppelin. So you also see a Tweeter app here. So this is what I'm going to demo. This is the demo pipeline that we were talking about. So we're going to run a Twitter clone. We call it Tweeter, and which interacts with all these services in your cluster. So if I go to Tweeter, it is running on one of the public nodes that I installed on this cluster. So if I go on that, so I have the public DNS for that public node. If I click on that, I'd see the Tweeter app come up. So we can go ahead and tweet something. I hope it works. Yeah, it does. All right. So what we're going to do now is we're going to post around 100,000 messages to this Twitter app or Tweeter app and see how the data is flowing through it. And then we'll go to Zeppelin and see how the analytics are coming up and who's posting what and who is the user who's posting the most. So we're going to do that. So can you see the font here? DCOS Marathon app add. I already have it here. So this would run this JSON file, post tweets.json. It would run it as a Marathon app. So if you want to see what's in there, there's just an image which would go and post around 100K messages to that Tweeter app, and it's connected to the app through the Cassandra and Kafka nodes. So if we go back here, the other one, I should probably close this. We'll go back here, we see that the post tweets Marathon app is deploying. So right now it's staging. In the meantime, we see if it has any logs coming up. No, not right now. Probably take a couple of seconds. In the meantime, we can see, oh yeah, so we see the tweets coming in, And if we refresh it, we see that they're coming in one by one. So what we can do now is we can go to Zeppelin and see what's really going on. So I already have it hooked up. So we see that Rosalind has posted around 236 messages till now. So this is a really basic demo data pipeline that we wanted to showcase that runs on DCOS. And to talk about Flink, if you go back to Universe, I already have it installed, but I'm going to show it the installing of Flink once again. So it's available as a pre-packaged service in Universe. If you click on install and then advanced install, you'll see all the config options that you can change to install Flink. So in this case, you see the options to configure the service, then you can configure the job manager and the amount of CPU memory heap that it requires. You can change the task managers, the number of task managers you want to run, and the options for it. For security, you can add options for Kerberos and HDFS as well. So that's how it's installed here, and see that it's already running, and we can just click on it. So we see that you can now run Flink on DCOS. Yeah, that's all I had for the demo. Why don't you take it on?
Cool. All right. Does anyone have any questions about the demo? All right. Well, we'll take some further questions at the end, too, if you think of anything. So as you can see, it's pretty easy to get this stuff going. Hey, what is going on? Okay. Yay. So that's sort of the basics of how you install it. And again, since this is all open source, if there's an option for Flink that you're not seeing inside the little pop-up UI that Ravi just showed there, you can submit pull requests against the repository to make changes to the configuration of Flink and to the options that are being passed along to Mesos via Marathon. So that's cool stuff. So, next slide, please. There we go. So, as I mentioned, I sort of wanted to go into some of the 1.9 features, just because they're with this release, there was a lot of focus put in the operations stuff, which is of particular interest to me, and I think a lot of people at this conference are the ones doing the deployments, right? Are the deployers, operations people here? Some? Okay. So one of the things that we did is, in addition to Apache Flink, there was support for a lot of other things added to our universe with this release. So we've got, and improved support for the existing ones. So we've got things like Couchbase and Elasticsearch and Redis and all these applications that are now part of the package universe that you can install with one click, and of course Flink. So that's improved a lot. Getting into operations, I'm sort of going to go through all of these one by one. But again, there's this thing we're sort of calling day 2 ops. Every infrastructure project has a really good story for deployment. Like you launch the thing and it's running great, but then you have the maintenance burden, and you have debugging, and you have logging. And if I'm really honest, DCOS could have done a lot better at this, and now we're really working towards that with the 1.9 release that just came out. So we now have this remote container shell. So you no longer have to do something crazy like SSH into a container, right? So you already have access to all the underlying technology. Why don't we just allow you to remote in with a shell? So now we have that. So that's pretty cool. So you can log into them just to do some fiddling around with your running application after you've deployed it, and you can execute them while things are running to do some troubleshooting if something's gone wrong, or just take a look at some log files or do whatever poking around in the container you need to do, just with this new task exec from the DCOS command line tool. We can also tune access, so you can give a specific developer access into one of their containers. So if their app is running and things are going wrong and they're like, just give me access to the container, you don't have to give them access to an entire host or everyone else's containers. You can just say, here's your container, just pop into it and do whatever you need to do in there. Unified logging is something that we're pretty proud of. Used to be that logging was kind of disparate, and it was kind of hard to associate a specific like application ID or container ID as you trace it through the stack in DCOS. So you'd have a deployment, and the Mesos part might be slightly disconnected from the thing in Docker, and then your marathon definition may not strictly track to it. So we've put a lot of work into aggregating all the logging so that it all goes into one place. So you can track these IDs as they go through the system, and then you can debug where the problem is. I think we've got a few logging technologies that are supported, but you can spit this out to an Elk stack or Kafka or something pretty easily. So it just integrates with existing log systems that you may already have running. We also are working on unified metrics. So with this release, you can, again, track your container IDs and your application IDs through the system and find out where things go wrong. So you can track metrics from this. If you want to, you can write some monitoring on top of that to see when things go wrong and track it through the system. And so you know where to pinpoint things when things go wrong. And again, this sort of integrates with existing systems because it doesn't use anything proprietary or weird. It has some pretty basic formats for how the metrics are consumable. And again, tracing it all the way through the stack. We have some more deployment debugging. It used to be if your deployment failed, things were kind of you didn't get a lot of indication as to why that happened. It would just be like, it failed, and here's some logs, which may or may not be useful. So there's a new UI for this, so you can see where things failed. And there's a lot of improvement to be happening here, but it's really exciting to finally have a visualization of more of the failure stuff, because that was actually really hard to track. And again, since you're working with a really complex stack here, I mean, we've got like the base operating system Linux, and then you've got Mesos, and then you've got DCOS, and you've got your applications running containers. It was sometimes hard to track where the problem was. So by having this failure debugging tooling, along with the metrics and the unified logging, it's a lot easier to track down where things are going wrong. And then, of course, with this also, you can see where your resources are allocated. So if one node is using a ton of CPU for some reason, and another node is RAM starved, you can understand that is happening and perhaps do something about it. Another thing that's getting improved a lot is upgrades and configuration updates. For now, we just have this shell script that will generate an upgrade script that you can run on all your DCOS nodes to do an upgrade instead of just tearing it down and building a new one. This is something that we're working pretty hard on, and in future releases, there'll actually be like a UI component. I was actually doing some user testing. Am I allowed to talk about it? Where I was like going through the upgrade UI that they're putting together, and it's pretty cool stuff. So you'll be able to do upgrades through the UI of DCOS and upgrade of configs and the subsequent restarts that are needed for those things. But for now, there's a shell script. You can dig into this shell script. It's not that complicated for generating a script. And then you take that upgrade script, put it on your node, and then run the upgrade node script to get your node upgraded. So we're well on our way to making sure upgrades are much easier and you're not just dropping and replacing nodes anymore. The last thing I want to talk about with DCOS 1.9 is that with improvements to the underlying technologies that we're working with, specifically Mesos, we now have support for pods, which is like co-locating of services. You can tell them, like, I want all these things to be together. And also GPU-based scheduling. That was a huge thing everyone was asking for. They're like, we have GPUs and we want to use them, but Mesos and DCOS do not expose them to us. So I think it was Mesos 1.1. It was the one released back in November, is when pod support was added. So again, it's just co-location. You can schedule multiple services on the same physical location, so that things are put closely run together that make sense. a couple of the use cases here. One of them is just migrating legacy apps to containers. We've all run into the problem where we want all of the things we run to be like stateless. We want it to all call out to external databases. We want, the load balancer to be in a completely different area. But legacy applications not necessarily in this perfect world that we want to live in anymore. So we're making it easier to migrate those out by offering pods, which allow co-location of services. So at least they're closer together, and the latency problems that you might see if something is like put in one part of the data center and then something's 4 racks over, you've got some latency there that legacy applications may not be used to. Being able to co-locate them together is a huge help. But probably my favorite example of this is like what we call sidecar containers, where you have things that are very like related to each other. So you have your application running, but then you also have your monitoring agent. Now you don't necessarily want to run your monitoring agent like on every single container that you're running your application on. So the monitoring agent can be put in a pod with your other containers so that they're still isolated, but they're really close together, so that you don't have any latency problems when it's looking to do the logging or the monitoring. Of course, things like backup tooling. I mean, you don't necessarily want your backup script running somewhere across the data center, which is then sending your backup somewhere else in the data center. You want, backup tooling to be really close to your application so that it can, execute and run quickly. Things like proxies. Again, you want your proxy to be close to your web interface, your web front end. And things like, if you're talking about streaming data, like event publishers, right? You want your creation, the thing creating your data to be close to your streaming application. You want Flink to be near whatever is feeding into Flink, so you can co-locate the pods that way. Or you could make it so they're not. So telling things like, I don't want these things together because there's some HA concerns, perhaps. So with the Mesos support, and then now with the DCOS support with 1.9 that we released a couple weeks ago, you can now configure pods through the DCOS interface. And again, pods are actually, they're just a JSON file format that's very similar to a marathon definition. And you can just upload that through the UI or through the command line or using the API. And then GPU support. So this is something that's also pretty new in Mesos, but then we pulled it into DCOS with this past release. This slide, if you don't know what GPUs are. But, we're entering an age where Moore's Law is starting to fail us, so we're looking at things that, besides just raw CPU, that are going to be helping our applications run faster. So faster memory, faster disks, faster network. And GPUs are actually starting to play a big role in this. So with the support in Mesos, we worked with NVIDIA and their GPU department to start putting together a really good GPU support in Apache Mesos, which has been pulled into DCOS. So in addition to CPUs and memory and whatever storage constraints that you have, GPU is now something that you can specify. So that's pretty cool. You can now share GPUs across your Mesos cluster. And then this slide, just a bunch of other things that is better in the latest DCOS release, newer versions of Mesos and Marathon. Support for latest versions of Docker. One of the things that we've struggled with is that Docker changes really fast. Maybe you've noticed. It sometimes breaks us, but we've been adding support for the latest Docker releases as quickly as possible. DCOS mostly runs on CentOS. We're working on Ubuntu support. I'm like a Debian person, so I'm all, can't come soon enough. But we're now supporting, in addition to CentOS 7.2, we're 7.3 supports in this release, as well as one of the latest CoreOS versions. Because again, for that underlying base in your operating system, or in your data center, you want a pretty basic Linux operating system. So CoreOS works there. We've done a lot of work in networking. So the networking plugins that you can choose to use for your container networking, there are improvements there. And then lots of other fixes and improvements to our CI testing so that we know that things actually work when we commit the code. So yeah, that's pretty much DCOS 1.9. And now we have question time.
You mentioned about upgrading Mesos. What will happen to the running applications on Spark streaming or Flink streaming when you upgrade Mesos?
So I think you can help me out here if I get this wrong, right? So the point of a Mesos cluster and using Marathon with it is that everything is distributed and it's a big cluster, and you have Marathon who wants to restart tasks and reassign things when things go down. So what you're going to be doing is you're going to be upgrading your data center piecemeal. So you'll be upgrading certain pieces of a few nodes of Mesos at a time. So presumably the workload will move. I can't speak specifically to like what happens in the microseconds during that move because I'm not actually sure.
I was wondering if there is a downtime on Flink or.
What was that?
If there's a downtime on Flink or Spark streaming application when you upgrade.
Yeah, I'm not actually sure. I'd have to look into like the HA options for it, because since you are able to do HA with Flink, it may just be like it just shifts the data over to another node. But yeah, I don't know the specifics. Sorry.
That's okay.
All right.
And I have one more question. I saw the Zeppelin is 0.5. So if I want to get a new version of Zeppelin into the Mesos, what's the...
Yeah, so if you want to get a new version of Zeppelin or anything really, if you go into I use Linux. I don't use a Mac. I'm gonna just make a mess over here. Okay, so let me just go into the packages here. I'm just gonna pick a random one here. So let me just click on this. So if you go into the advanced installation, in addition to having the specific ones, now I don't know where it is. Oh, no. Maybe there's not one for this one. Okay. Where's one that has a place where you can define the URL? So like you can actually define a URL with a version. I can't guarantee it's going to work brilliantly. So what I'd actually suggest, instead of just, so Zeppelin, is there a way to define?
I'm not sure if Zeppelin has it, but if you want to run a newer version of Zeppelin, then one way to do that is run it as a Marathon app and configure all the options. But I think the packaged version is 0.56, so if you wanted to run a new version, then you can either package it for Universe or run it as a Marathon app. Those are the two options.
Yeah, so some of them will have like a URL where you can just put in which version you want to use if you want to change from the default. I can't guarantee that's always going to work because we haven't tested it. But I'll also say that, again, like all of these definitions and all of this is open source. So if you were working with a newer version and you wanted to help everyone else out, you could do a pull request after you test it on your own. You could do a pull request against our repository and update the version that we're using. And that would be awesome. And we will look at it and everyone will be happy. So thank you for the question. That was a good one. Thanks. Other question? Oh, sure.
Yeah, I have a question in the context of Flink, but I imagine it might generalize to other things you might want to run on DCOS. Something you want to do with Flink is like include some other files, maybe some jars to put on your class path, something like that. Is there kind of any common pattern in DCOS for like you want to be able to use those nice applications, but maybe you want to modify the container when you launch, something like that?
Yeah, so in the Marathon definitions, there's a whole section and a whole ton of documentation about storage. So you can load up external storage where these files live. So storage could be made up of anything. It could be like an NFS share or whatever you're going to be loading things up, or just block storage somewhere that you happen to have in the cloud that you're using, maybe using S3 or something. So in the Marathon definition, you would typically load up whatever storage and whatever files you want to have access to that are already put somewhere else in storage, and then attach them to your container. Do you have anything to add? All right.
Cool. So like the S3 example, it could like sync down some files into a certain place. Okay.
Exactly.
Cool.
Yeah.
Thanks.
Sure.
Could you add a little bit more context to the demo, like how everything was fitting together? You just deployed all these apps, but then they all fit together.
So we showcased two demos here. One was the demo data pipeline, which used Spark Cassandra, Kafka, and Zeppelin all linked up together. So when I ran that app, Tweeter app, so it was trying to communicate with Cassandra and the Kafka broker nodes. And after that, I ran another Marathon script which would post multiple messages to that app. So that's how all of them were connected together, and we were able to see how the data is flowing in and what the stream looks like in Zeppelin. And the second part of the demo was just installing Flink.
And also our Tweeter demo is on our GitHub repo, the Mesosphere GitHub repo, I believe. So you can actually look at, I think is it in Python or Go? I don't remember, but whatever language it is. You can see it actually passing the default URLs for things like Cassandra and other things. So it's like the script is actually going in, like auto-discovering a bunch of stuff to actually hook everything together. So that was the Marathon definition, right, you said? Yeah. So that's actually what's tying all this stuff together once you get it all up and running. And that was a good question because that was not clear. So thank you.
So the pods looks very useful. So the question is, are those dynamically reconfigurable? Can I add services or delete services from the existing pods?
Yeah, and you can kill them as well. And with Marathon, since it's a scheduler, that's essentially an init system. It'll automatically bring things up if you kill them. So you can kill a bunch of things and it'll automatically reschedule them. But yeah, you can also do... you can add more. I don't remember what it does when you actually change a config on a running task.
So if you change the config, it will redeploy it, build a new plan for it. While the new one is coming up, the old one will keep running, and when the new one comes in, you can apply it throughout the cluster.
So redeploy it where? In another pod or what?
Sorry, say that again.
Redeploy it where? What do you mean redeploy it?
So let's say you wanted to increase the node count for one of the services, Cassandra. So when you do that, the config changes. So what the default scheduler for Cassandra would do is it would restart the scheduler, and Mesos will tell it now the Cassandra wants 4 nodes, and it would start staging the 4th node and reinstall the scheduler 2, which interacts with all the 4 nodes that are now in the cluster.
Okay, thanks.
Dus applaus.